Welcome to stream number 61 in this series where I am programming an NES game live on Twitch from scratch. So let's get started here. Sorry about the sort of schedule being all over the place lately, but as things are kind of hopefully settling down a little bit, we'll have more regular hours here instead of doing the Monday, Thursday, Monday, Friday shuffle. We'll stick with Monday and Thursday, or I may end up having to. I don't know. Maybe I'll change to not do it on Thursdays. I don't know. Let me know if different days work better. Can always change it up if it makes it easier for people to watch it live. Assuming that it's easier for them to ask questions when it's live. One of the questions I got on I don't know if it was a recent video or not, I don't remember, was about how another game does its scrolling. And I answered that on the description, on the recording comment, but we can talk about that here. I said I would. And I think it's useful to show how I arrived at the conclusions I arrived at. I might have been wrong. I don't know. I didn't really spend more than about 10 minutes just kind of looking at what the game did. And so the question was, how do you do something like four-way scrolling like they do in the game Pirates, which is based on Sid Meier's Pirates? It's just an NES port. How do you do four-way scrolling? There are multiple different ways, but let's look at how they're doing it in particular. So let's fire up Messin here. So the first thing I looked at was I looked at the information about the ROM itself, the header. And I noticed that it's mapper 1, which is, I believe, MMC 1. So let's take a look at the mapper reference at NESDev. So if we look at mapper 1, yep, it is indeed MMC 1. And then, let's see. Is it using, it's got 128K of program ROM and 128K of character ROM. It doesn't have any RAM. So what that says to me is that it's not doing anything tricky like the game Metal Storm, which I'll show you sort of as a contrast to how they tackled some of the background effects that they're doing. So I have really no idea how to play this game. I just literally went as basic as possible. I got past this part here. Although, you know what? Actually, let's restart it for a second because there's something interesting to show. So MMC1 has the ability to do bank switching, which is interesting because when you look at the PPU, so this is pretty normal looking. One thing you'll notice, I'm apparently having streaming problems here, and I got disconnected from the live stream. Okay. Let's try reconnecting to the stream here. There we go. Sorry about that. looks like maybe the internet is being a little flaky right now, so I got disconnected from the stream. So one thing to note here is when we opened the PPU viewer here, we could see that it's not doing any sort of horizontal or vertical mirroring. It's actually using, it's got the same screen across the board. And if you look at what's defined here in terms of the name table mirroring, it does support what's called one-screen mirroring. So there is the possibility of saying, you know what, there's only one screen, and we're not doing horizontal or vertical mirroring like we would in the shooter game. So what I wanted to show you was when you go into this and you create your character, Mr. Zed, as I am an English buccaneer. So one thing that's kind of cool to see is this. I can't make this bigger. So what you can see is that the text is here, looks fine, but the portrait of the player does not look correct. And the reason for that is they're using the bank switching. And so once they get finished drawing the text here, if I change where we're refreshing on the scan line, eventually what'll happen is you'll see the portrait will pop into place, and oh, there it went too fast. The portrait pops into place and then the text becomes wrong. And that's because the emulator is, when it's drawing the screen at the particular scan line, it is looking at the character ROM at that point in time. And so the neat thing about that is you can see as we go back to different scan lines, the character ROM should be different. Let's see. As the bank switch occurs. It's interesting. Why is that not... I wonder why that's not... unless maybe it's using... You know what it could be? It could be flipping between this bottom position and then this top position. That would make sense, because then it's not even switching banks, it's just switching positions that it's reading the character ROM from. So that's one trick that they're using to be able to display more than they would have otherwise. Alright, so now here's this part where you kind of use, I don't know, the weird fencing mechanic here to you know, kill this guy or whatever it is you're doing. Anyway, so the point was to get to a point where we are sailing, so we can look at the scrolling. So again, if you look at the name table viewer, you can see that it's just the one screen there, and it's scrolling the land into view. Oh, I crashed. All right. The other interesting thing about it is you know, so other games use a technique that's similar for scrolling, where they're updating both the row and the column at the same time, and what you end up with is a lot of times you know, sort of this weird discoloration. So if you've ever played Super Mario Brothers 3, you'll see that. And that happens as you scroll, and it has to update the attribute table on the background to match the proper palette set, or even potentially a new palette set that wasn't loaded previously, in the background. And what you can see is that they're really only using 3 colors for the background. And then for the little huts and the clouds, which you can see are over here, they're sprites. And it looks like, to me at least, that they're just basically doing simple updates to the name table. Let's see, so if we do, what we can do is even slow down the emulation so that we can maybe see what it's doing. Yeah, so I don't know if you saw, if you're looking over here, you'll see that an entire row will pop out of the tile memory. And because the ship is scrolling relatively slowly, the effect of that popping in and out of view really doesn't have much bearing on the smoothness of the scrolling. The other thing they do that's really nice is they have these waves here that they generate out of sprites. It's a pretty cool effect. It looks good. And again, because they're using simple colors that they're not changing, you don't end up with a problem where the colors look off. Apparently the men are restless because we've been sailing with nothing happening. But again, so, you know, it's just doing the same kind of thing where it's updating parts of the name table as we scroll. But my guess is that it's probably using the single screen updates because it's simpler to update that, you know, consistently. Well, maybe not. Maybe it's... I mean, we could look at the assembly and see. I keep opening the wrong freaking thing. Now, this is obviously going to be a little bit tricky because we're going to be looking at just the raw assembly code, but let's see if we can see anything that would kind of clue us into how it's handling the scrolling updates. So let's slow down the emulation, and we can hit a breakpoint here in NMI. Now, so the interesting thing is is it not using the NMI? It's not hitting the breakpoint for it, at least. So I wonder why that is. That's kind of interesting. So let's pause for a second and see where we are. So this looks like it's different. You know, the other possibility is that when it paused, maybe the prog ROM, the code ROM bank that was being used was not the one that we had selected. Well, the address would be the same. I'm not sure why it wasn't breaking on it, but so we're here. So let's see if we can. So here are the scroll controls that it's updating. And it looks like it's updating the sprites to update, and then we've got, it's interesting that it does a store twice into the 2005 and 2006. Oh, I see, for 2000. So it's resetting the scroll register before doing some other stuff. I wonder why that is. Maybe it's something that I don't know why it would do that. Maybe it's something that's a better, gives it better reliability in scrolling or something. I don't know. Yeah. Keep stepping over, or what's going on, debugger? Oh, it's just in a loop there. Interesting. So, oh, I see. Okay, so now it's jumping to this. Does the sprite update. It's zeroing out 2006. Setting the PPU control to 0. So it's basically kind of like turning things off. And then it's looking at 20C0, which is, if we remember correctly, the beginning of one part of the name table. Right? 20C0. Where is that? 20C0. Somewhere over here. So that's curious. I wonder why. Or what it's doing to update over there. 20 to, oh, it's storing that into, yeah, so that's updating the address, and then any write to 2007 would store values in there. So it's zeroing out part of that. Interesting. And then it changed the scroll. Huh. So this is zeroing out part of the data at 20C0, and then turning back on PPU control. Let's see. So bit 8, right? 1, 2, 4, 8. So it's turning on, it's turning back on NMI, and then it's loading the new scroll position in, jumping to a subroutine. And it's interesting. So a lot going on there. I'm not sure it's something that we would be able to necessarily. Oh, that's interesting. So is the scroll? It's almost like it's doing updates. No. So, I mean, that's sort of high level. There's obviously a lot going on, and I have to spend a lot more time just going through the assembly to see what it's doing and why it's doing it. But hopefully at a high level it shows how you can kind of guess at what it's doing. Again, I mean, the code is right here, right? This is what's actually doing the work. The problem is, of course, there are no comments or anything like that, so it makes it a little bit hard to debug and step through and actually understand. What I wanted to show before we go back to the game was so this game is interesting because, like I said, it uses a different approach. So you can see that it's got this prog ROM and this character ROM. You know, it's funny. I thought it used RAM too, because there's this really cool effect that it has. But maybe not. Maybe that's not how it works at all. So you can see it's using vertical mirroring. But what I wanted to show was the... so this is, again, this is doing the updates like we're doing in the shooter game, where it is just a simple scroll, right? So we're just scrolling in one direction or another, and it's just updating parts of the background with it. Now, what's cool is this part. And this is part of the background, but you can see it's scrolling smoothly as we scroll, as we move back and forth. Now, what you can see is that these parts here are actually moving back and forth too. Now, like I said, I was under the impression that it might be updating character RAM, but actually that doesn't appear to be the case based on what the header says in terms of if it actually needs character RAM or not. So the question is it just bank switching? Maybe it's just bank switching. And that would make sense, because then all of the stuff that they do this kind of animation effect for, they could use the same bank here, and they all seem to be doing that same sort of scrolling effect. But you can see it gives a really cool look at it. It makes it look a lot more detailed than it really is. One more level, and then we'll get back to shooter. So Metal Storm password level 2. Just so I'm not sitting around trying to beat the level. It is a tough game at times. PS 0. Let's see. G H. And you know, this is not comprehensive, I realize. There's a lot here, and you know, if you want to look at something in detail, like how, for example, Super Mario Brothers works, there have been attempts made to fully disassemble that. All right, so yeah, so okay, so what they're doing is bank switching. It looks like this to create the animation effect. When you're moving back and forth, because it looks like this is the tile pattern here, right? Like that's tile AA, and that doesn't change, but you can see that the whole background looks like it's moving as you scroll. And so that would be, that's my guess, is that it's just switching the bank, which in the different banks that are there, the tile is slightly offset, giving it that ability to look like it's scrolling in a real like multi-layer level. I'm much better at this game than you would guess by watching me right now, but I'm distracted by looking at the backgrounds here. So anyway, if you've never played the game, I definitely recommend it. It's a great game. It's expensive if you want to get the cartridge. It's, last time I looked, it was like $90 or $100 for the cartridge, which it's a lot for that game. But it was one of those games that was not super well known. I remember renting it from the local video store as a kid, and thinking it was really cool, but I didn't have a lot of games as a kid, so it was one of those things where I rented a lot of games and got to try a lot of games that way, but didn't get that until much later in life to actually be able to play that. Alright, so let's see, what should we work on today? We're at a point where we have things being loaded from the project file correctly. It's loading the map properly. It's got all of the different pieces to it. One thing we're not doing is we're not properly storing information about the enemy, about the enemies themselves. Right now we are just simply storing that there is an enemy and what the location is. We probably want to change that so that we are now, we would now be storing the type of enemy as well. So let's do that. So this is our object layer. We can see that there is a GID, which matches up with the, well, we don't have it here because I removed it because it was causing problems with the export. So we can fix both of those things at the same time. So let's export that again so we get the fully correct export file here. Okay. So you can see GID 5 is the flyby, and it has the location of that tile set. Now, for this project file, we were including the flyby in the sprite list like this because there was no other way to do it at the time. But let's take it out, because it should be incorporated based on the level, because that enemy might not be part of that level. The main thing, though, is that we want to ensure that when we get down to this part where we're importing in the list of tile sets, we are ignoring anything that's a tile set for the enemies, and instead treating that differently, treating that like a sprite object. Or, well, it's going to be treated like a sprite object, but not included in the meta tile information that we're generating for the background maps. Because right now those are two separate things, right? The game is, and this may not be the case in the future, but for now we've sort of clearly delineated the game into two different parts of the PPU memory. So we've got the background content here, and we've got the sprite content here. I'm hoping we'll be able to keep it that way. There are things that we will need to be able to do to optimize the tiles that we're using, because right now we're not doing any sort of optimization. We're just purely importing things directly in. There are going to be things that, like we've talked about with sprites, where the player sprite will be mirrored potentially horizontally, because it is a symmetrical shape, right? The ship. And so that's one area where we can save some tiles. And same thing with this gradient. We may want to, I mean, we're probably not going to use that in the real game, but the main thing is that we should be able to, you know, either optimize this automatically if the gradient is consistent enough, or at some point come back into here and look at the meta tile for, where did that go, for the gradient, and start choosing tiles that are part of this, and because these are the 8x8 tiles, and choose these and kind of reuse them within the meta tile, so that we are manually optimizing it to get close enough. Like, we might say, you know, maybe there's some way we can use the gradient tiles from here over here if they're flipped, or here and here if they're flipped, but only the middle ones have to be unique. I don't know. But that's going to be part of what we're going to have to do as we add more content to the game and, you know, potentially run out of space. We do have other ROM swappable ROM banks that we can put stuff into, but we haven't done any of that yet. We've just got this 8K of ROM, which is the smallest, I believe, for MMC3. Do we still have that? I can close that. Doesn't matter. So let's fix the way that we're handling the import of the enemy, and then let's make it handle that properly as a sprite, and then we can hopefully get into a situation where we don't have to manually modify that JSON file, and then we can handle other types of enemies being loaded in. So it'll require modifying the asset tool to export that information correctly, and then in the assembly code, when we are calling this add flyby, we will need to look at what kind of enemy it is and add the appropriate one. So let's do that. All right, so right now we have our array of map objects, which just have an X and Y. They're just a vector 2, but I think what we want to do is we want to change that to actually be a type called map object or something along those lines, where it's got the X and Y and also the GID. So let's say type def struct so I probably just want to use, do they not define? Oh, not capital. Getting confused with the way it's capitalized in C#. So we have our int 8. I'm trying to think if we want to use 16 bits or 8 bits. I think 8 will probably be enough, because we're just going to have up to 255 enemies. I don't know. We'll see. Hey, mapk. Hopefully I said that right. Map PK. I don't know. Map sounds like the right way to say that. All right, so we've got our position and our GID, and then we want to change load map to Y. I don't know why that wasn't working, but okay. So this is game object, or no, map object, sorry. Which is going to break things, but that's okay. So let's go fix the things that we just broke. Sometimes that's the easiest way to make a change, is you kind of like make it in reverse. You define the type, and then you start with the functions that you're calling that you know, pass in the thing, and it's passing in the wrong type. And so you fix that, and then you kind of follow it. You kind of go back all the way to the beginning, and then kind of follow it back down your call stack to make sure that you're handling it properly. The compiler can help you find those things more quickly. We'll do that sometimes at work if we're making a large sweeping change to the way the code is working. You deliberately break it by adding in the change at sort of the lowest level and work your way backwards, because it makes it easier for you to find all the places that you have to change it, versus trying to do it without breaking things, and then it becomes very very challenging to ensure that you've gotten all the places that could potentially be affected by the change that you're making. Sometimes it's as simple as just renaming a variable somewhere to ensure that you are hitting it everywhere that you actually use the variable, because sometimes it's not super obvious. Defining a version of this here that works on int 8. And basically we can just steal this code and now, granted, I could probably call one of the other ones and do the cast in there too, but just in case we end up doing something differently for our conversion here, oh, but that's a sign. Okay, that's unsigned. Why did do I not have you? I mean, technically a byte is different than a... I don't know why I did it inconsistently like that. That was kind of weird. All right, so get property. Okay, so we've got our value is int 8. So that gives us our GID. So let's just make sure that when we run through this, we got 5. Yep. Okay, cool. So we got our 5. So that's good. So now what we need to do is after we're done loading the map, what we need to do is go through our list of objects, our map object count. And then how do we want to do this? Yeah, I mean, it's again, one of those things you don't necessarily want to be doing. So anytime you have something like this where you're doing, you know, you've got an outer loop and an inner loop, performance is not going to be great. However, we're doing this one time upon loading the map, so I'm less concerned about this. Oh, that's an int pointer. Than I would be normally. If you were calling this over and over again, that might be a signal that you need to figure out a better way to do this. Like I said, we're doing this once. The maps are not that big that it's worth optimizing how that particular thing works. So let's see. The meta tile count is the thing that we want. Oh, are we not saving that somewhere? Okay, so we're using it here. Let me declare it outside so I've got that. Don't have to guess. Uh, 16. All right. So we have our meta tile count now. And basically what we're doing is we are saying, okay, let's look through our meta tiles. If we see that any of them have the GID of an object, then we want to remove that from the meta tile list. Now, the problem with this is that we have our list is static, so it's going to be harder to manipulate the list the way I wanted to. Let's see, we've got all of this stuff. So what we can do is we'll make a separate list that we just copy over the content. That'll be faster, I think, and easier. So what do we want to call this? We're going to make this. Do I want to make it dynamic? I don't. I really don't. Temp meta tiles, max meta tiles. Initialize that. All right. And then so what we want to do is for each of the meta tiles, I'm going to reverse what we're actually looking at. So the other thing we should probably do is let's throw an assert. Just want to make sure that while we're working on stuff, we don't get into a situation where the meta tile count is actually bigger than the max meta tiles that we support here. for some reason, which would cause memory corruption. All right, so right, we need a semicolon there. So we're going to loop through the meta tile count and then check each one against the objects. You know, I'm just going to be a poop about this. I'm going to be stubborn and still optimize this, because it's bothering me that we're going to do the inner loop when we can do something really simple that will make this work. So what we can do is we can say a uint8 of map object GIDs, and we know that max object GIDs, we know that we're saying we're only using a byte, so because we're only using a byte, we can allocate. We could do this with less memory, but then it's really getting crazy here. So basically what we would do is we say, okay, we have this GID, and we'd say, what did I call it? Map object GIDs. So basically all we're going to do is set the index to 1, right? Really simple. And then for the meta tiles, oh, so that's a good point. So for the meta tiles, we're not actually storing off the GID anywhere, and we do need to in order to make that. Oh, we do. Okay, we have it. It's called ID. Are we? I think we're loading that. I don't know why I called it. Tile layer. Map meta tile. Let me see here. So this is going through the tile sets to load the ID up. Let's take a look at this data here. Oh, it's called first GID here. So let's make this more consistent with the other thing. Let's call it a GID. Just so that it's got the same name there, and we're actually comparing things that will make sense later. And so basically what we want to do is we want to look at the list of meta tiles, and now we have this array that if we've looked at this meta tile where the GID matches the GID of this guy, for example. So we've looped through here, and we get 5, and we see that yes, there were objects in the object layer that had the GID of 5. Then we know we don't want to include that. The reason we're doing it in a separate temporary buffer is because we don't want to have gaps in the meta tile list. So int current meta tile position equals 0. All right, so if map object GIDs so if it's 0, then well, no. So if it's not equal to 0, then we want to skip it. right? Because that means it was used in one of the map objects, which means that we don't want it to be exported as part of the meta tiles for the background. It's a sprite meta tile or sprite tile set. If it wasn't set, what we're going to do is we are going to do a mem copy to temp meta tiles, current meta tile position. We want the address of that, and that's map meta tiles I, and it's the size of map meta tile, and then technically, just as a side note, technically we could do this because it's a post increment, so it would execute the line of the mem copy and then increment current meta tile position. I've been burned by that kind of thing too many times at this point. It's just better to break it out into a separate line unless you really want to do it as compactly as possible. It's just, I mean, it evaluates to the same assembly language I would imagine, in some way. It's just a syntactical thing that you can do. Doing it before, if for example, I wanted to increment this before I did the mem copy, right? It's the pre-increment. I can do that. So it would increment current meta tile pos and then do the mem copy. But again, it's just unnecessary cleverness that will confuse me later. So it's worth noting that in C++, if you're doing increments and you are working with objects, so for example, you're incrementing a vector object. Let's go into that for a second. So if you're doing something like for standard vector int, you know, I equals myvec begin. I think this syntax is basically right. If it's not exactly correct, then, you know, hopefully you'll get the point. So if you do this where you're using the standard vector I and you're saying I want to go from the beginning to the end, and then you're doing the increment of the iterator. Oh, I think it's what is it? Iter, like that? I forget now. It's been a while. It's better to do the pre-increment on that because unless something has changed, my understanding is that the compiler will create a copy of that iterator object and then do the increment afterwards because it's a post-increment if you did the I++, and so the pre-increment operator is more efficient for loops on objects where you're using an overridden ++ operator. Again, that may have changed in the last 5 or 6 years since I've done C++ in any quantity, but it's just something to be aware of because maybe it's not properly implemented in all compilers, or you're using an old version of a compiler that didn't do it if they've figured out a way to optimize it out. So it's just kind of out of habit that I always do the ++I or ++ anything versus the I++. All right, so anyway, where was I? So I'm incrementing, I'm looping through the meta tile count, and if the GID was set to a value here, then I am going to continue because I don't want it in the temp meta tile list. So I will then copy it if it's not been updated, and then increment this, and then when I'm done, I'm just going to do a straight out copy of the two things. So map meta tiles, temp meta tiles, size of map meta tile times I think it's max meta tile buffer. So there is the possibility, that's another thing that we should check for probably. If max meta tile, assert max meta tile buffer is less than or equal to map max meta tiles. Again, these are more for just making sure that we don't run into weird problems down the road if we have to increase sizes and don't remember to change it everywhere. Yeah, so here then we just copy the content from temp meta tiles over to map meta tiles and we're good. So let's check that code out and make sure that we're actually good. All right, so here are, so map object GIDs should have only one thing set, which is 5. So this is like a really naive and super basic implementation of something like a map or a dictionary, where you would use a key to determine if it was, you know, used or encountered before. The idea being that searching through that is going to be more efficient than searching through a list by iteration, because especially if you're using something like a string as your key, you can hash that, or the dictionary implementation hopefully hashes that and gives you a faster lookup that will be closer to a constant time lookup. The nice thing about this is because we're using byte range of values, we are getting a constant time lookup for whether or not the object was used in the list of enemies that we have to spawn. So we just kind of loop through and we look at whether or not it was used in the set. So map meta tiles I, let's just look at that as we scroll through. So gradient is good, it copies that over. Blue tile's good, green tile's good, bumper's fine, flyby, so this is where we should continue on and not copy it over. So it did, that's good, that's what we wanted, because we don't want that to be part of the meta tile set. So if we look at temp meta tiles, we can see that we now have gradient, blue tile, green tile, bumper, and we don't have the flyby. So that's good. All right, so then we're going to do our mem copy from temp meta tiles to map meta tiles, where max, yep, that's good. Max meta tiles is 100? Yes, it is. Okay, good. So map meta tiles should now have the same information. It's not resolving it because it thinks it's just a pointer, but we can look in the memory here and see, okay, we've got the gradient, we've got the file information there, and then we've got the blue tile, and then we should have green tile and bumper, and that should be it. Yep. And so another thing that's worth noting, if you're doing Windows programming, Windows will populate memory that's been invalidated by like a string operation after a null termination with this FEFE. That's if you're running in debug, that's a good way to determine why the memory has certain values in it. It does something similar for when you allocate in free memory. We can look at that in a second here. But so that's good. It's got everything the way I wanted it to. So now the only thing is that for the map object, it's not loading the flyby in here anymore, but that's okay. So we'll get to that in a second, just to show you what I was talking about. So we have this temp buffer. Right, so we have this this value, and then we mem set it to this buffer memory, and we mem set it to, let's say, 0, as you do. And then I free it. What you'll see is if we look at the memory in the debugger here, after it's been zeroed out, we're going to free it, and you can see, yeah, so the debugger initialized, or sorry, free under debug mode initialized all that memory to D. And so if you find yourself working on something and it's crashing because of an invalid memory access, and you go and look at the memory and you see, oh, it's got a bunch of D's in there, it's because you know that that memory was freed by a call to free. I think it works similarly. I want to say it probably works similarly in the C++ stuff. We can even try it. In other operating systems, it works differently. This is a Microsoft thing. In IBM, I believe uninitialized memory, if I'm remembering correctly, is initialized to dead beef. In Hex, I think I've talked about that before just because it's kind of funny. So that's a call to new. Oh, except you don't want to use free on that. You want to use delete. So if we take a look at temp buffer, it's zeroed out as you'd expect. And when you, okay, same thing. So free and delete are doing the same thing. It's initializing the content of that memory to D. Again, only under the debugger. At runtime, it doesn't do that because it's aiming to run it and compile it in an efficient way. So all of that stuff is overhead that it doesn't include. That's just to help you when you're debugging. All right, so we're loading the map. We have our map objects. All right, so now what we need to do is we don't have the sprites being loaded from the map objects that are loaded here. And if we go to this, I don't think we have enough information. We don't have enough information, but let's see, how can we fix that? Because what we want to be able to do is we want them, well, I guess we can copy that over. Well, for this, we just know that it's 5, and then 5 relates to this, which would allow us to do, so you know what we can do? Let's add yet another parameter to load map, shall we? Let's call this map metatile object metatiles. Max object metatile buffer. And what we want to do, instead of doing the continue here, yeah, that'll work nicely. So what we can do instead is say current object meta tile position equals 0. So we'll put it into this map object meta tile list. So map object would do memcopy map object meta tile buffer. No, that's max. What do I call it? Map. Oh, object metatiles. So object meta tiles, current object meta tile position. And then we're going to copy this guy here. Size of map meta tile. And then we'll continue. So basically, if this meta tile is actually used by the map objects / enemies, then copy the content to the object meta tile list so that we can load it as a sprite. And this needs to be capital. And now this call breaks because we're not passing the right number of things into it. But we also need to create I apparently have Discord still running. Go away, Discord. Thought I shut that down. Okay. Okay. So I guess I'm using this in a couple places, so let's fix this. Okay. So now what we need to do is, after we're done with that, we want to add to the file list, we want to add the object meta tile. So int I is this, and then max meta tiles. And we are basically going to stop at the point where the GID equals 0. Otherwise, we're going to add it to the next current file list. I think we can just copy how this works. Where? This one here. I can literally just be able to copy that because it's, well, yeah, it's the same thing essentially. Boo. Let's make that a function. Right? File system item. So we'll call that map meta tile to file system item. And just because in case we need to change the way this works, I don't want to have to change it in multiple spots. So so the file system item is current file list, current item count. That obviously needs to be the address of the thing. Come on, type type the right things. Map, meta tile, tiles I. So that's just that, and it cleans that up a little bit so that the loop is a little bit more readable. And then rename this. And this becomes that. That becomes that. And then this should be this. Because we do not want to manipulate current file list directly anymore. And then we need to move this out. All right, so this should be included. So item index. Okay, so this should be current item count. Okay. Now, the nice thing about this is that I just take this and I make it do this for object meta tiles. What doesn't it? Expression must have a class. Okay, something got mangled up here a little bit, but that's okay. That's good. All right, so what did I not do right? Fine. Unsigned end pointer. Sure. You're right. I'm not being consistent. Oh. All right, so if the GID is 0, then we're done. Otherwise, copy it to this thingy, and that should be that. That should make it work the way that we want. We can actually use... all right, something else got busted, but hold on a second. We can actually change this to use the same approach. And just say, oh, but it's not a, okay, never mind. It's not a map meta tile like the other one is. Okay, so what did I break in this? So item index is 0. So we're gonna, let's look at FSI. We've got these, the name and the path. So that's the file, that's the name of the file. It's not a directory, the file size we don't care about. So now we're gonna increment the, oh, that's the problem. Ah. Okay. Okay, it's not the end of the world. It makes it a little bit odd. Far. Okay. So it's going to use, it needs to increment the index, which means that it needs to use the index, because the point of incrementing the index is that it is accessed, it's accessing the item and then the next item in case it is loading the meta tile if it exists, which makes sense based on the way it was originally written, but kind of just got a little goofy by factoring it out. It's not that big a deal though to change, and it still effectively works the way that I want it to. So let's take a look at that. So now, oh, you know what? The only thing that I forgot to change was, instead of passing the address to the current index that we're operating on, we're just passing the array as a whole, because it's going to figure out where in the array it's working on. It's just the meta tile that we're actually updating in the list that needs to be different. So okay, so we've got that. FSI index. Okay, so we increment that, and then let's see, we got the full name there, so that becomes that, and then we got to replace, and if it exists, it does exist, so we put that there. Yeah, that looks right now. We're still getting the full name there, but we are seeing this now, so that's good. Just not handling the sprite file itself correctly. Why is it getting the full path? For the name. Good question. Did I not? Yeah, I didn't change that properly. Okay. So, yeah, there we go. Much better. So these are all working now. So now the only part that's not working is for the sprite, because for the, okay, yeah. So we need to do the same thing here with this. And there it is. Awesome. All right, so now in theory, when we export the project, things will have worked, but we will see. Let's take a look at, oh, I don't know. Let's see what metatile char has in it. Okay, that's good. It doesn't have the flyby in it. The palettes, entities, that's good. Draw entities, this still has flyby. I think that actually worked, because everything is split up now into the background, into the sprites the way it's supposed to, be, but without me having to manually remove the flyby from the map like I was doing before. So in theory I should be able to take this now from the export and replace it all here, and rebuild and relaunch, and get the same functionality as before. Except that it is, what, not sorting the sprites properly, or sorting the enemies properly, potentially. It's odd that that would be a side effect of that. How... Oh, you know, maybe in the way that we're exporting the enemy list here, I maybe messed something up. Let's take a look. Map object count. Well, that looks right. It's... So that's the X position, that's the Y position. And if we look at the map objects, they should be sorted in descending order. So 2900. Oh, that's interesting. Why? Is the X and Y reversed? Let's see what got botched in that. So X is 10, Y is 2900, so that looks good there. And then the next one, 2899 and 44. I wonder, am I, oh, you know, maybe. Yeah, that's why. Okay, so this was just a mistake on my part. So it's when it's doing the sorting, it's doing in-place copies of the content, just doing a mem copy. And if you don't change to the new size, you're not going to get a you're not going to get all of the members of that structure copied over, which means that you are going to get very strange results, which is what we were seeing. So let's try that again. Okay. Well, actually, you know what? Let's just double check before I go through the process of getting that into the export. 2899, 2898, 2898, 2897, 2896. Okay, that's looking good. Cool. And the export process is that. And let's rebuild. And oh, I guess I closed it. And now we should be seeing, oh yeah, there are all the enemies popping in. Cool. So obviously there's no hit detection or anything there, but we can still shoot them down, so that's good. That means that that export worked properly. So now the last thing that we need to change is we need to change the way we're doing the export of the enemy information to include, I guess we want to include, I guess we want to include the GID. I'm not sure if that's going to be a good thing to map to or not. Let's look at how the export, well, So the export is exporting the entities that way. So flyby is 4, which is that. At a top char. So what we would need to know is we need to we'd have to map that somehow. You know what? We'll do that for next time, or maybe I'll do that separately so that you don't have to be sitting through that process. But basically, what we'll do is we will write out the GID as an extra byte here. Right? It's just one. It's not a vector 2 though. Oh. So that is our single byte value. So that's going to break the enemy functionality when we do the export now. But that's okay. So that's good. Let's close that. Export. Oops, too far. All right. And then in the assembly code, right now, all we're doing is we're looking at the index and we are all right. So here, let's see, we were doing times 2 plus one more index in order to get times 3. It's times 4 now, right? Because we added, it's 4 bytes. So now we can just do 2 shifts. So that saves us some. And then that first one is no longer the X. It is, this is the enemy type. And then increment Y, and then load a level object data Y, and that's our X, and that should be it. That should fix the problem that was created by adding that extra byte. So let's confirm that. We don't really care about the value right at this second. I just want to make sure that the enemies spawn. Yep, and they do. Okay. And we exploded. All right, so then all I want to confirm at this point now is that the value that's being loaded here in the enemy type and stored in temp2 is actually the enemy type. So it should be the value 5. And if it's 5, then we're good and we'll wrap for the night. So it is every time. Okay, great. So that means that's working. So now we have to figure out some way to map that to the call to add the appropriate enemy type. Right now we are calling this add flyby. But really, you know, this doesn't need to be, that doesn't need to be specific to flyby. That could be, yeah. So what we'll do next time is we'll change the way that this is working. But right now it's specific to flyby because we're hand coding the setting of the value in the entity type to this hard coded value. But basically, it would be whatever the enemy type is, or it doesn't even have to be an enemy. It could be anything, right? Whatever the type is that we want to represent on the map, we would store that in the entity type. And this code is going to be the same. And we can actually, let's rename this. Let's call this, instead of add flyby, add map object. right? Because more generically, it will support now adding any object to for the map. It doesn't do that right now, but it will. All right, cool. So made some good progress there, and we're like really close to wrapping up the work that I wanted to do to reorganizing how we're handling the map level loading and conversion. Still waiting on what's going to happen with art for the game. I need to do some independent work about what the actual design will be beyond, flying around and blowing stuff up as you do in a shooter. I've talked about some of the design elements, but I need to do some real play testing and experimenting with things before we start implementing anything here. And that's not something that lends itself really well to on-stream sort of time. So I will do that over the weekend, and on Monday we will come back, and hopefully the enemy portion will be done so that we don't have to work with that too much in the asset tool, but we can start looking at how we're going to implement some of the design ideas. Maybe we'll have some art, I don't know. But as always, thank you for watching the stream live, for those of you who made it in. And thanks for watching the recording. If you're catching this later on YouTube, feel free to ask me any question you have. It's been great seeing people asking questions about how things work on the NES. There have been a few people who have come in who are using NES Maker, which is a tool that was kickstarted a little while back, where they're trying to make an interface for building NES tools and providing sort of code templates that you can use to make sort of simple games and get something running on the NES real quick. I don't know a whole lot about it, but people have been asking questions about NES programming because they've started looking at NES Maker, and they want to understand more about what's involved in the process of making the games more unique. Because while you can change the included templates and the projects that they've been outlining in NES Maker to be different, making them drastically different and not look like obvious changes of the provided NES Maker code, requires actually going in and changing the assembly code, which is not something that's obviously taken up lightly by especially people who don't program and who were looking at this because they were interested in using it kind of like RPG Maker or something along those lines, or Game Maker. But anyway, so yeah, feel free to reach out to me on Twitter at Clarvis. Post questions or comments in the description below the video on YouTube. My email, I've added it to the bottom of the screen under my picture. It's the Gmail address that's there. But yeah, and also come to Discord, say hi, ask questions. There are a bunch of really smart people who have made some awesome NES homebrew games on there, including Derek from Gradual Games, and Kevin from Kahan Games, and Bo from Soul Goose Productions, and Brad, who made Lizard, and I'm gonna leave people out. Nathan, who made Anguna, and Roth, who made the Black Box Challenge. And so anyway, lots of really cool people there who have made a lot of amazing things, whether it's a full game or tech demos, or been with the community for a long time. And it's definitely worth checking out if you're interested in NES programming at all. So with that, have a good night, have a good weekend. See you Monday, and thanks again. Take care.